Hello, my name is Pieter Janssen. I would like to talk with you about applying artificial intelligence to cybersecurity in these very interesting times. So in the next few minutes, I will talk you through kind of the problem we're solving, because you don't just start using AI, you need to have a problem to actually solve. You need to have data, and I would like to show you some examples of how we do that. But first, little bit about the company. We are a Dutch cybersecurity company, and we basically hack our clients. They order us to do that. We do it in an automated fashion. So we are a Dutch cybersecurity company using a SaaS solution to help our clients become more secure and to protect them against the next generation digital threats. So we often say, we hack you before they do. But first, what we always say is that tactics of the attackers only change when they stop working. So we've seen some movements and would like to share my insights on these movements. If you look at the chances of getting hacked on your working at home environment, so the remote working environments like Citrix and etc. So the chances of getting hacked as an organization last year were rated as medium. And the impact of a hack, when you actually have been hacked, were also rated as medium, because there's always the option of just going to work and log in at a physical computer and then continue doing your work. So we would say the impact is some in the middle. But then, yeah, we kind of have a completely new era of working now. You cannot go to work if your remote working system does not work anymore. So the impact of a hack on your remote working system, your VPN systems, is actually very high as an organization. It completely disables your people from communication and actually getting some work done. Now, what I also want to show you is that the chances of getting hacked on your, in this case, remote working infrastructure have also increased. So you can say the risk has increased and the impact also has increased. So it's a different game. And if you look at the traffic statistics of the Dutch national infrastructure, so this is our Amsterdam Internet Exchange. What you see here is in February this year, we had an interesting spike in traffic, or a dip in traffic. And if you look what happened is, I will translate this one for you. Globally, there was panic around Citrix because Citrix was vulnerable to being hacked and there was no clear resolution for it yet. So a lot of organizations said, and also the Dutch government advised, turn off Citrix if you can do without it. So that's what a lot of organizations did. And we had massive traffic jams on the road. So fast forward to today, the era we're currently in. It's a bit different now with working at home, because if you compare this year's February to last year's February, you see that there's a decrease in traffic. And today it's a huge amount of extra traffic that we have seen here as soon as we started the lockdown, the smart lockdown that we have in the Netherlands. So again, the impact of a hack on this would be pretty much. If you look at the chances, why we say the chances of getting hacked are increasing, it is because we also see, when you look at the cybercrime underground, that most of these cybercrime organizations are actually monetizing their services in a way that they are providing cybercrime as a service. So in this case, these four, so to say, mafia-style mobsters have decided to switch to cybercrime because it's a business that's easy to do when working from home. They also are experiencing lockdown. And if you look at some of the attacks, this is an example attack that we have spotted in the Netherlands, targeting the Dutch health organization, coordinating all the pandemic efforts. There was a fake website set up called www.rivm, that's the name of the organization, but it becomes weird, nlgoogle.com. That's not correct. That's not the official site. It was a fake site. And there were multiple sites like these. And if you look at the statistics on the right, it's the charts of all the pandemic-related domains that we publish. We refresh the list on a daily basis on our website. you will see a tremendous increase in traffic. And we see targeted attacks from these websites delivering specific types of malware, exploit kits, ransomware, actually trying to profit from the urgency of this crisis. It's terrible that this happens, but we need to be aware and we need to be vigilant about this. And this is not a local problem, it's a global problem. And you've also seen it when in Germany, when the first announcements were made, which organizations were actually responsible for distributing the coronavirus aid loans. These banks were immediately targeted with fake websites, fake portals where people could log in, apply for a loan. Then they probably had to transfer a little amount of money in order to actually get the loan approved. And these scams we see a lot, and these really follow the news. So I told you about the problem. This is the problem that we are solving for our clients. It's about phishing, it's about shadow IT, it's about finding holes in your infrastructure. And that's a lot of data, and the amount of data is increasing every day. So if you are applying AI needs data. So one of the things we use is advanced image recognition. Take this lion, for example. We're very good at hunting lions, and we try to spot them in the wild. So we generate these key point images, and we then try to map these images to each other and try to identify resemblance and similarities in the images, which allow us to say, okay, this is certainly one of our target logos that we are monitoring. So we see, if you look at the results, it works pretty well. And also when logos are a bit skewed, for example. So how we train these algorithms, just a little bit on that, and there's here more proof that we are very good at spotting these logos even when they're on not so clear spaces. One of the tricks that I'm sharing with you right now is how we are doing this, because you need a lot of data on one end on the input side, so you need a lot of images to train on. On the other hand, you need to process the large amount of data that we see, all the amount of websites that we see, and we need to check if these images that we are monitoring are actually present on these fake websites that we are trying to identify. And if there's a match, if there's a logo of our client on such a website, then it's a hit. Then we need to investigate it, and then we need to take it down to protect our client. We have a lot of data in terms of new websites, fake websites, but we don't have a lot of input data on logos because organizations don't typically have a lot of logos. So that's when we play a trick on the artificial brain. What we do is we generate, based on the official logos, we generate fake images, we twist them a little bit, and we train our algorithms to recognize these images as being related to their logo. And at the same time, we also feed the same algorithm images that are clearly not related to the brand that we are monitoring. So in this example, on the left, there's images that a human knows are related, but for computers, it's pretty hard to find the difference between the images on the right. So this is how we train these algorithms. Using data, if we don't have big data, we generate the big data ourselves. So there's a lot of data that we process, and that's when it becomes interesting, because a human can, of course, find patterns. We know when websites are coming from Russia or China, and related to our clients, they show the logos, it's typically bad. So that's a pretty easy rule. We can hard code it into the platform. It's easy. But when it becomes more interesting is when you have this large amount of data, you want to see if there's other patterns that a human cannot spot. So we let our platform learn based on known bad websites. And we let the platform group them based on the features that might be interesting. So we look at a lot of parameters, and one of the insights I can share with you, that if, for example, a website is ending with an extension of .online or .top, it has a very high chance of being a fake website. And why is that? It's a very cheap top-level domain. You can get a domain very cheaply there. But on the other hand, we also see a lot of criminals using .inc as an extension. It's a very expensive extension. So what these criminals do, they buy with a stolen credit card, they buy such a domain, and by doing that, they want to generate credibility because it's an expensive domain. So it's very interesting to look at these outcomes, and these are just some of the many examples that we have spotted in the wild when looking at that large amount of data. Another thing I always say is that AI needs visualization, and especially in cybersecurity, where it's very hard to explain a non-technical person what cybersecurity is. That's also something we really focus on, because what we want to do is we want to explain on a boardroom level how our AI platform actually helps them protect their infrastructure. And this is an example of how we visualize that. So within that sphere, you will see the digital footprint of an example organization. And all these connections, these represent pieces of data that are located within their infrastructure. And we give an indication, in this case, the color, that's what the AI platform does. It gives an indication of how hackable that piece of infrastructure is. And if you look beyond that sphere, we will also project attacks on that. And these attacks are similar looking websites that are most likely going to attack our client. This is what we do with AI. This is how we visualize cybersecurity. And this is how we want to contribute to making this world a little bit safer, especially in these interesting digital times. Thank you for your attention, and have a pleasant day.
Hello and welcome to my session. My name is Sinisa Patkovic. I'm based out of London area in UK, but I work for a Canadian company called Icera. Icera is based out of Waterloo, Ontario, and Icera is the leader in quantum safe cryptographic solution as well as crypto agile solution for enterprise and OEM space. Today I'm going to have about 10 minutes to talk to you about the importance of preparing for quantum threat, and we call that quantum readiness, and why it impacts different industry differently, as well as what's the meaning of crypto agility and why enterprises need to start looking at it as soon as possible. So if you look at my slide, there's something called Shor's algorithm there, and asymmetric cryptography. So the reason why there is so much work in this area already, and why the quantum threats being so much spoken about, is that the ability of quantum computer that is expected to happen between 5 to 15 or 20 years from now, which is less important, and I'll show you why. The quantum computers will be able to run Shor's algorithm, which was invented in the 80s, and it's quite well understood that it will be able to break classical asymmetric cryptography and essentially render those keys that can be 256 or much larger than that. All of them, regardless of the size, they're going to essentially decrease the strength to 0 or make them invalid. And why is that so important? Is that because symmetric cryptography is very hard to be used without asymmetric cryptography. Quantum computer will not be able to fully break symmetric cryptography by using Grover's algorithm, but it will be able to decrease the strength by half. However, using symmetric cryptography is close to impossible without asymmetric, and most people in security understand that. The asymmetric cryptography is underlying just about everything we do today, everything on the internet, everything we do corporate-wise, all the different protocols we use in our society, from banking to conferencing, do have some sort of asymmetric cryptography that's used to share secrets or to authenticate, validate, provide for digital signatures, and so forth. So we've never seen this type of attack. It's essentially a tectonic impact, tectonic shift that's going to happen in cryptographic sphere domain, and it's essentially something that will cause all of today's present digital identities, digital verification schemes. It will cause them to be rendered completely inviolable, broken. So an attacker with access to a quantum computer that's able to run Shor's algorithm will be able to take any readily available public key out there of any type of system or service and derive the corresponding private key. That means that the attacker will be able to easily forge a digital signature, for instance for a software update, and the system loading the update will not be able to distinguish the forged from the original authorized signature, and the systems will simply be compromised. That's just one of the examples of how quantum computers will forge signature. So everything we use today is going to be broken. So what are the examples of systems where this is more relevant early on, even today or yesterday, perhaps in some situations? Future-proof communications, for instance. These are any type of communication where the content or the secret communicated needs to remain confidential for more than a few years, say 5 to 10 years or longer. This can be state secrets, can be corporate, trade secrets. It doesn't matter. And the reason these are impacted today is because of the harvest and decrypt attack, where an attacker is able to get to the data through any means available. And this is not very difficult to do. It's a very simple student-type university exercise to do that. And decrypt this data later on when they have access to a powerful enough quantum computer. Another type of system under impact or solution is authenticated software over-the-air updates for complex devices. This can be vehicles, particularly you can imagine autonomous vehicle, and ability to load a forged, rogue, malicious software onto such a vehicle is a tremendous threat. You have jet engines in airplanes. You have many other thousands of examples of complex systems that have a long design cycle and that also have a very long life cycle, going to be out there for 10, 12, 15, 20 more years. And then another example, particularly in the enterprise, is the identity and access management systems. Public key infrastructure that underlines the trust in most companies. These are very hard and slow to migrate, and that's because the PKIs have been designed to work with only one public key scheme. And so Icera has done quite a bit of work to provide for technologies that enable a hybrid approach, so that one X509 certificate and PKI system and CAC card and the whole ecosystem can essentially talk both to the legacy system using classical scheme and talk to the new systems using the quantum safe scheme. An important item is to understand why not everybody is impacted at the same time, and this is because of these different product life cycle lengths and design life cycle lengths. We do not know when the quantum threat is going to manifest itself. It can be anywhere between 5 to 20 years from now. We know that NIST is standardizing a number of asymmetric schemes, and that's expected to be out there in 2024. And some device manufacturer can afford to wait around that date because they have a shorter design and lifespan of their products, such as smartphones. But then there's many others that essentially need to start working on it immediately, and many have started working on it immediately. And this includes both enterprises with complex PKIs as well as OEM manufacturers, system-on-a-chip manufacturers, and so forth. These are the examples of the industries we've already worked with, that we've already supplied our expertise and solutions to: aviation, silicon, chipset manufacturers, enterprises with PKI, smart card and common access card vendors, and many other ones, including the certificate authorities and HSM vendors. So there is a growing interest to understand how they're going to be able to run quantum safe algorithms, but also how their solutions going to fare in terms of the requirement to be agile, to be hybridized in the future, in that there's going to be a period of time where we'll likely going to be running both classical and quantum safe algorithms simultaneously, and that requires tremendous agility from all infrastructure, from platforms for different systems you do have in the enterprise. And this is what Icera provides. So Icera has, we have a toolkit that's been out there for a number of years now that has the implementations and wrappers and integration tools of different asymmetric algorithms that are in the NIST competition, as well as we support algorithms such as stateful hash-based signature that are already validated and proven to be strong and that can be used today to solve some of these issues that I've discussed. We also have Catalyst Agile technology, which enables a hybrid X509 certificates, which can carry two different public key signature schemes. And we do quite a bit of professional services as well to help customers benchmark their future architectures and come up with a better PKI migration strategies, for instance, in financial services and in government. And we do have a number of partners and case studies already. You can see them listed here. So we've done, I would say, quite a bit of work across multiple industries already, both in enterprise government, automotive space, chipset manufacturers. We've done work in aviation industry and so forth. So, and there's going to be more and more of that in the future, as obviously you know that the quantum threat's coming near, and the NIST standardization is coming to an end. So this is the way we recommend the customers, both OEM and enterprise, to approach quantum preparation for quantum readiness and quantum threat, essentially to identify some of their products or systems, such as PKI, that will be under impact and that take a long time to migrate and prepare, and to work with their board to explain the threat to the enterprise or to the product, and to essentially come up with a essentially start small, have multiple milestone approach, and the good beginning is a good proof of concept that can be done within a year. So we've done a number of these. So this is a really good start. And then the immediate next step that will come out of the first step is essentially to be able to roadmap the agility within different types of systems, platforms, and products you have in your infrastructure. And that will essentially lead you to understand how you're going to implement quantum safe solutions. And then agility is a critical topic because everybody will need that better visibility and ability to manage and report on cryptography in their infrastructure. So this is the way you can get in touch with me. Thank you very much for your time, and I'm going to be answering Q&A questions as well. Thank you.
Hi everybody, a warm welcome from my side. My name is Michael Teixeira. I'm CEO of the Giesecke & Devrient Group, and I'm quite happy to have you all here in the stream for our next Tech Days 2020 session with the title OpenTitan, Open Source Meets High Security Chip Design, the first open silicon root of trust. To discuss this quite interesting topic, I do have two top experts in that field with me today. First of all, it's Dom Riso, tech lead for OpenTitan at Google, and in addition, Felix Miller, a hardware security expert and technology advisor at Giesecke & Devrient. So, hello Dom, hello Felix, pleasure to have you here today. So,
Hi.
Right. So
Thanks so much.
Let's get started. So maybe I start with Dom. Dom, being more or less the father of the OpenTitan, what has been the motivation of Google and you personally to start a project, to get it kickstarted?
Sure. Yeah. I'm happy. First, thanks for having me here, and I'm happy to speak to that. So from Google's perspective, we really, I'd say it's three things. It's sort of concern, opportunity, and experience. So we actually have our own proprietary internal root of trust that we use, which we'll talk about a little bit more later, probably. And this is not that, right? This is a completely, new project. So we looked at the kind of field of the root of trust technology, and we were very concerned about sort of lack of transparency in those implementations, which is, one of the reasons we built our own. But we also saw kind of a lack of coherency across implementations. They sometimes provide different or inconsistent security properties, which is quite difficult for us to manage. And so, at the same time, we saw a set of credible partners, kind of the rise of open ISAs, things like RISC-V, And we saw an opportunity there to address some of the shortcomings we saw in the current Silicon Root of Trust technology. So we saw this opportunity here to increase transparency and security industry-wide, and so we went for it, right? For me, personally, I believe that security is a right, not a privilege. So I want it to be ubiquitous and from the ground up, right? I want to root it all the way down in the hardware at the very, very lowest layer. And so I also believe that our users and our customers shouldn't have to just trust us. So I'm very committed to this notion of your security implementations should be transparent, they should be open, they shouldn't be inspectable, and they should be as, basically as visible to the world as possible. So that's really what we're doing with OpenTitan, is we're taking a very secure piece of technology and just making it open and transparent so that we don't have to ask people to have that level of trust.
Yeah, cool. So can you elaborate a little bit, so how what you said, the intern one, the Titan one, and the OpenTitan projects, how they are related? Is there a connection?
Sure. Yeah, no, I'm happy to. So Titan is a moniker for a family, actually, of secure silicon ICs that are proprietary to Google, right? Where we have that level of transparency that we feel we require to meet our kind of Google planet scale network security needs and requirements. So OpenTitan it's a distinct project, distinct code base, although a lot of the same people are involved. And it really builds on our experience developing those secure ICs, but in a way that's open and accessible to the rest of industry. Okay. So that's kind of the interrelationship there.
Yeah, cool. So Felix, so what was then the motivation of you and GND to join this initiative together with Google?
Yeah, sure. So back at the time when we first met, or actually before we met, I was part of a team that was looking into new architectures for hardware platforms for integrated SIM cards and integrated CQ elements and things like that. And we were actually looking for partners in this area. And then a former colleague of us who was also part of this team, he introduced us to the Google OpenTitan team. And we met twice in Munich. So Dom and a couple of members of his team came over twice, and we were discussing. And it was clear when we compared the architectures. So I still remember us sitting in the meeting room and looking at block diagrams. And we saw that what we came up with, and we had in mind that this was pretty similar. And it was clear that we would both benefit working together there. It wasn't technical aspects only, though. I already knew some of the engineers from the Low Risk team in UK, which is now also part of the OpenTitan team, and the non-profit organization there, which is managing the project a bit. And so I knew together with them and together with a tech giant like Google, it was clear that this is the perfect setup for a project like this. So we joined.
Okay, great. So Dom, we all know that Google has great developers, and why did you decide to go for a partnership approach instead of just open source the existing Titan design and tell the world, oh, look, that's how we do it, and we don't hide anything. So to generate this transparency you talked about earlier.
Yeah, so we didn't, I'll just take them in two separate bits. We didn't just open source it for a few reasons. One, the Titan chips are actually built around some proprietary cores, so that's kind of a non-starter. We would have had to replace a lot anyway. Okay. And two, I don't really believe in the style of open source where you just sort of push something over a wall, because we find that those projects tend to have longevity problems, they have support problems. So really what we wanted to do was expose kind of what we were working on midstream, I would say, mid-development, so that we could get additional people involved, additional feedback, kind of get buy-in kind of across the board. And then finally, we went for this partnership approach. And I want to kind of note here that OpenTitan, Google's a major supporter. I kind of founded it inside Google, but it's actually been moved outside of Google. It's administered by the Low Risk CIC, a third-party not-for-profit. And we really did that to kind of make sure that there was a long-term home that's not really just kind of centered on one partner, right? So that we can bring in people like G&D, we can bring in people like, Seagate and Western Digital and Nuvoton, all of our other partners as well. So we went for this approach because we really, we're good at some things, but we don't know everything, and we really want to leverage both others' expertise, but also their interest and sort of getting those all aligned so that they're also benefiting, so that they're bought in, so that this thing really becomes as ubiquitous as humanly possible, right? And the only way to do that is to really bring in partners and kind of understand their use cases and their requirements, and make sure that we're building something that is sort of maximally useful to the largest number of people.
So a great win-win situation at the end of the day, right?
Yeah, absolutely.
And can you briefly summarize maybe the key benefits and principles of OpenTitan from your point of view? Maybe you can illustrate it a bit.
Sure. Yeah, I'm happy to. So let me just try and find the right slide here for just a second. So 3 key principles: transparency, quality, and this notion of being community driven. So transparency is this notion that your security shouldn't rely on secrecy. It's commonly known as Kirchhoff's principle. So the idea that anyone can inspect, evaluate, and contribute to the design. And so we have a very open source, very kind of traditional open source structure where there's a steering committee and a technical committee, and all these things get reviewed and put out in the open, right? Like you can go to OpenTitan.org and have a very, up to the minute snapshot of what it is we're doing and what discussions are being had and what technology is going into the silicon IP that we're building. The other one is, the next one is quality, which is, a high quality design is a secure design. It's also a highly manufacturable design. Mm-hmm. So we have a lot of requirements around, it's great to build IP and contribute that, but we also require that there be design verification IP, that there be kind of a basic set of software drivers that goes with every IP block, that this stuff is thoroughly tested, but also thoroughly documented, and that the interface is very standard across all of our different blocks that are within the chip itself. So this is, to increase adoption, but also to make sure that we're building something that is very, industry best practice, functional, very effective, right? And then finally, it's community driven. So like I said, it's actually administered by this third party not-for-profit, the Low Risk Foundation, or the Low Risk CIC rather, in Cambridge, UK, who have a lot of background and expertise in sort of engaging with the open silicon community, the open source community, and really, helping us make sure that we're running this project in a way where all the partners benefit, where we really are bringing the best expertise that's out there to the project, to the table. So.
Okay, cool. Understand. Felix, what are the use cases G&D has in mind, and which markets maybe you are planning to address with that?
Mm-hmm. Yeah, so as G&D Mobile Security, which is a subsidiary within G&D I'm personally part of, we plan to enable OpenTitan as a security endpoint in mobile devices. And the most prominent use case for this is mobile network authentication. So in cellular networks, so basically what a SIM card does today. But there are also other use cases. Things like firmware updates over the air, device management, automotive use cases, security tokens, IoT products like smart meters and the like. So especially the IoT space is very interesting for us. And there again, it's both. So it's mobile network authentication, and there in particular IoT networks like low power wide area networks like narrowband IoT and CADM networks, but also other security use cases in the IoT space. And we believe that there's a very large benefit for chip vendors and OEM in adopting OpenTitan as a security anchor in their design, just because it offers a very low entry barrier for those companies. It's essentially for free, right? And this is crucial for smaller businesses, especially in the IoT space.
So at the end of the day, you're bringing the root of trust to everywhere, yeah?
Right.
But does it mean, I don't think so, that G&D is aiming to become a hardware manufacturer, to go for a hardware product?
No, not really. So we don't plan to become a silicon company on our own. So we believe in the platform effect of OpenTitan, so that many companies will adopt it, that many silicon companies and many OEMs will adopt it as their security anchors in their devices. And this is what we prepare the G&D ecosystem for. And this is both. So this is the software that runs on the actual device. So it runs on OpenTitan, but it's also the backend. So the server systems, the server infrastructure for device management and these things.
Okay, so the lifecycle management is also key. Okay.
Right.
Okay. So let me allow one side question beside the OpenTitan. So in the world of G&D's products with this high security, certified products, high confidentiality for implementation and so on, how does that fit together with open source? Is that a match or not?
Yeah, this is something that might look contradictory in the first glance. However, we see it more complementary. So with open source, you get the review by a large company. So you get a lot of people looking at it, inspecting every detail. And if there are any vulnerabilities, hopefully, or most likely, someone will spot it. Plus, you gain a lot of trust, right? So everybody can look at it. You show that you don't have anything to hide. And also with a open hardware project like OpenTitan, this goes beyond just open source software, right? You can even inspect the hardware design. And this is what open source brings to the table here. What certification and common criteria brings to the table, what we are used to at G&D, is that this product or the system, the architecture is vetted by experts from the security community. And by this, I'm not saying that through the open source aspect, you don't reach security experts. There will be a lot of security folks in academia and serious cryptographers looking at the design. But I'm talking about the experts that have access to high-end lab equipment, like laser fault injection or atomic force microscopes and things like this. This is something that you get with certification and common criteria. And if you bring this together with open source, you get even a higher coverage of security assessment in total. And also a common misconception is that that certification requires you to keep everything proprietary and hidden, but this is actually not the case. It's much more about integrity and showing that no one can tamper with your design during production process, for instance. And this is something you can also guarantee with an open source project.
Understood. Okay. And Dom, how is, from your point of view, so OpenTitan different from other open hardware projects? Is it similar, or do you do something differently?
Sure. I'm happy to speak to that. And I think that is actually one of the ways in which we're very different from other open hardware projects, is in sort of our completeness and thoroughness and the quality of our design, right? So we're quite flexible as a project, but one place we're quite rigid is in our requirements for documentation, testing, and design verification for the implementations that we take responsibility for. And because we do have access to the full sort of logical source of the chip design, you can imagine that there's places where we can use some of our pre-silicon testing, and we can sort of reuse that for post-silicon testing to validate that the two work the way you would expect, right? It's not a perfect solution, but it is quite a bit better than I think most implementations can do today. So, what I would say is, a lot of what we do isn't flashy. It's kind of, a lot of it is the seemingly boring hard stuff. Like, I don't think it's boring to write documentation, but not everyone necessarily agrees with that. But that kind of collateral is actually what makes our implementation, I think, more valuable and more useful than say just like an RTL IP implementation, right? It is the fact that we include the thorough documentation, the thorough testing, the thorough design verification IP that really sort of makes this such a high quality proposition to build this root of trust.
Understood. So you mentioned a lot of partners and peers in that project. How did you choose the set of partners?
Yeah, so we actually spoke to many people, and you know, I take a very big tent approach to this. You know, all interests, all contributors are welcome. But what I will say about our first round of partners, and honestly, G&D was actually our first official non-academic, so first official
cool.
commercial partner, and I greatly enjoyed working with you all and Felix and the rest of the team. So what I will say about this first round of partners is that they're all, excuse me, very enthusiastic, very, you know, they sort of understood the value of open source, and how it aligned with their interests, right? You know, I'm almost looking for people who want to do this out of selfish means, and not just because, say, you know, Google is involved, and that we actually feel like that's what we found in our initial set of partners. So, you know, we want to create something that's long lasting, and like I said, not really overly reliant on any one participant. And it's really our project partners that make this successful, that make this a long-term proposition, that sort of really like spreads the support burden around. And we absolutely, you know, neither Google nor Low Risk nor anyone else, we really couldn't do it without this network of strong partners and partnerships.
Okay. Felix, so being a partner in that project, in which aspects of the project does G&D contribute, and in which field are you personally active?
So we are in particularly, of course, interested in the high security area. So we want to enable it for real high security use cases where certification is a topic and these kind of things. So we contribute in the area of certification, obviously. So this is where I'm personally active a lot, and also in the area of cryptography, like cryptographic accelerator, these things. Then also, of course, we want to run our software on it finally. So it's also topics like lifecycle management and the hardware-software interfaces. And also, other than that, we just contribute generic engineering resources. So for the day-to-day businesses, working on the repository, working on issues there. Okay.
And on Google side, so what are the main use cases you want to apply the OpenTitan?
Sure. So let me expand on that a bit and say not just, you know, Google's use cases, but really where we see this being applied to the industry as a whole, because you know, it's a generic root of trust, right? So we started in our technical infrastructure group. So we will move to using this as the root of trust for our internal server and other hardware designs, network cards, things like that. But again, it's generic, right? And we expect this widespread adoption, like your use cases, other use cases. You could, you know, for example, use this chip, use a discrete chip or even an integrated one as the core of a second factor device, like a security key, delivering like user level protections, individual level protections. If you wanted to be really ambitious, you know, you could even say it's the sort of thing that could be used as a root of trust for consumer hardware, laptops, phones, that sort of thing. Which I think is, you know, a pretty interesting future direction. And what we think is that by making this design open and available and very permissively licensed, right? It's all under an Apache license. It's all free for use, although not the trademark, to be clear. We did that to avoid artificially restricting the applications, right? So, you know, we're starting in this server root of trust space, and it's sort of over time has been branching out from there. It turns out that a silicon root of trust finds a home in a lot of different locations.
So time is running. Maybe as a final question, really beside this topic of this session today. So everybody of us is affected by Corona somehow, can feel the impact. Did Corona also impact the initiative, or how did you manage to cope with that? To the question to both of you.
So I mean, it's I'll start, and then Felix, I'd love to get your perspective as well. So I would say, you know, there's been an impact, but it's we are a large, probably 60, 65 people all told, spread across 5 or 6 different organizations. We're kind of built to work in this large distributed fashion. So, you know, as I'm sure many people are experiencing, we're seeing some of the most severe impacts for those folks with children and childcare needs. That's a very consistent thread. But on the whole, you know, we're we're handling this reasonably well, I would say, all things considered. I'm understanding and happy of where we are given the circumstances around COVID these days.
Okay.
Yeah, it actually, I thought about this a lot also personally. And interesting thing is, for me personally, it didn't change that much, other than that I'm working from my living room now. But it was even before COVID, as Dom just said, it was a project with collaborators from all over the world and working from many different time zones. And we had some face-to-faces in the beginning to get to know each other, but day-to-day business, it was driven by video calls, by working jointly together in Google Docs and the repository, of course, and issues there. And before COVID, we had maybe 4 or 5 participants in the meeting, and those participants were meeting rooms in Sunnyvale and in Boston and in Munich and in Israel and in Cambridge. And now we have, I don't know, maybe, what did we have, Dom? 50 people in one of the large meetings, right? So it's you get a lot of peaks in people's living rooms, but other than that, it works really well. And so we are in a good track, I think, and we are lucky, I guess, in this whole situation.
I would say yes. You get peaks in people's living rooms, and there's a lot of like pets and dogs and children in the background passing through, needing one thing or another. So that's it's fairly entertaining, actually. So, but yeah, I think we're doing pretty well.
It becomes a little bit more personal, huh?
Yeah, absolutely.
Yeah, certainly.
Okay. Yeah, cool. So I think we have to close the session. So Dom, Felix, thanks a lot for your time, giving us the insights to the Open Titan project. It was really a pleasure for me today to be the host of the session. I hope to see you next year face-to-face again, and that you can give us some updates how the progress on the project was. And thanks to everybody in our stream. Enjoy the rest of the Tech Days 2020, and bye-bye.
Sure. Thanks for having us. Bye.
Thanks so much. Cheers.
Thank you. Bye.